Hi. In this third part of the project, we will be exploring the model which relates the clinical data, RNA, and proteomics data. What we were doing in the first two parts were individually taking each data sets, clustering them, trying to find out what the important features are using random forest algorithms. But in this video, we would be relating three different files to identify which is the mislabeled sample. Uh, in this approach, we will be identifying mislabeled for MSI values.
Now we will go through the proteomics data and how it is related with the clinical data. First step would be importing the libraries, then loading the clinical data in Target and extracting the MSI, as we are going to do clustering on basis of MSI. As we can see, the target has been successfully loaded, and in order to check that in YMSI all the MSI labels are extracted, we'll be showing that by YMSI. Now for feature selection, we are going to load some tab2.csv, which is the label, which is the target of proteomics, and I'm going to load that in Y. After that, we will load the proteomics data and check if it has been loaded correctly. As we can see, it is loaded correctly, and there are few missing values which are represented by NaN. I'm going to take a transpose, as there are 80 training values and in the data there are 80 columns, so I need them in rows. As we can see, the transpose is successful and the training 1 to training 80 are now rows. We will replace the NaN values by the mean value, and as we can see over here, it has replaced all the mean values with the NaN values. Using random forest classifier, we are going to do the feature selection. So first would be importing random forest from sklearn, after which we will be training the X data, which is the proteomics data, on label, which is Y. Once the model has been trained, we will do feature importance and we will display top 10 features which have the most importance. As we can see, these are the top 10 features having the greatest importance. We will extract them in columns and select the top 8 features, as we can see over here. After extracting those columns, we will extract the training data of training 1 to training 80 samples for just those reduced columns. So till now we have done the feature selection and removed the features which are of less importance. After this, using these 8 features, we will divide the 80 training samples into 4 clusters. For that, we will be using unsupervised learning method, which is k-means. So first would be importing the k-means from sklearn.cluster and creating 4 clusters, after which we will train and then predict in which cluster each training sample belong. As we can see, training 1, 2, 3 and 4 belong to cluster number 2, and so on for every other cluster. So for 80 training samples, it has divided them into 4 different clusters. In order to check that which particular training sample belongs to cluster number 1, 0, 2 or 3, we will run a loop and push all the training samples which are in the same cluster. So for clusters 0, if yk means of I equals to 0, we will push all the training samples in A. Similarly, if they belong to cluster 1, we will push them in B, for cluster 2 C, and for cluster 3 D, in order to display in which clusters do the training samples belong. Now we want to see that we will compare the training indices with, so for training sample number 14, we want to check which MSI does it contain, if it is MSI high or MSI low. Similarly, for all the training samples which are in one cluster, we will check which MSI label does it have, and we will do the clustering on basis of majority of the MSI labeling. So as we can see, for all the training samples in A, the following are the MSI labels, and we can see that the majority is MSI low. So we will filter out those which are MSI high and put all of them in A refined. We will do the similar for B. Push all the refined in B refined. Over here just one is mislabeled, which is MSI high, as it is not the majority, so we will remove that and push all the others in C refined. Same with D. So after pushing all those which are majority in a cluster based on MSI label, we are able to get that there are total 62 training samples which are correctly labeled, but this is not accurate. So in next video we are going to do clustering on basis of male and female, and then check it with the output and see if we are able to get more close. Now we will move on and do the same approach for RNA.
We have already imported the libraries. Now we're going to load the RNA sequence from SumTab2 into our target Y. After which we are going to load the train underscore RNA into the data, which is actual data. Now to check if all the data have been loaded into my data, I use this command. I want to transpose this 80 columns and 4118 rows, so I'm using this command. Now I can see that some of my data has an NA value, which is not applicable value, so I want to replace that by the average or the mean. So I have done that, and I am seeing if that is done, which is, it is. Now this is the target which I had loaded. The target which I had loaded over here. I just want to check if it is all there. Now I want to reduce the features. So I will use PCA to reduce the features, PCA. And I have reduced 10. I have extracted that I want 10 top features. So these are my 10 top features. Now I'll perform k-means clustering on them. I've created 4 clusters, and I will do k-means.fit and k-means.predict to get that which training sample is in which cluster. So I can see here that training sample I can see that training sample 0 is in second cluster, training sample 1 is in first cluster, and so on till the 80 till all 80 clusters are into one cluster. Now let's perform random classifier. This random classifier will give me the importance of each and every feature that I have extracted. This is in the columns form. So there are 79 unique. Now I'm going to perform k-means on those x reduced. So my y is into one of the 4 clusters. Now I'm going to match my cluster pair with the MSI lower high, and that's what I have done here. After which I want to keep them into these arrays. This is for A, B, C, and D. Now I want the refined one. This is A refined, that is B refined, C refined, D refined, and I'm going to add them up, and when I do, I see that there are 63 correctly labeled while 17 are mislabeled.
Thank you.